Dear students, myself Mr.P.P.Sutar, Associate Professor, Department of Chemistry, Gopal Krishna Gokule College, Kolhapur. Now in this class of B.Sc. Part 3, in the CBCS pattern for semester 5, you have to learn paper number D.Sc.E-E8 of chemistry, also called paper number 12, which is of analytical chemistry. And from this, we are going to learn chromatographic techniques and quality control. Now, the topic includes the introduction part and classification. Now, in the introduction, every chromatographic methods consist of two phases. The one phase, which is a stationary phase, which is generally of solid or liquid, and another phase is called as mobile phase, which is generally of liquid or gas phase. Here are the various techniques of chromatography, which consist of column chromatography, planar chromatography. In the column chromatography, the stationary phase is held into the tube, which is made up of glass or metal. In the planar chromatography, the first variety is of paper chromatography, which is carried out on the plain paper. The second variety is a thin layer chromatography, also called as a TLC. Here the stationary phase is sprayed on the glass plate using slurry, and that works as a stationary phase. In the techniques by physical state of a mobile phase, here the first variety is of gas chromatography and the second variety is of liquid chromatography. In the affinity chromatography, the supercreated fluid chromatography is the technique. Now, in the classification of chromatography, the classification is based on various mechanisms. The first one is the mechanism of separation. Here, the mechanism when used adsorption, the chromatography is known as adsorption chromatography, and when the mechanism of separation is a partition, it is the partition chromatography. The classification based on the phases. When solid phase chromatography is studied, here there are two varieties. One is solid liquid chromatography and another is solid gas chromatography. As I have told, every chromatography method consists of two phases. Here the given solid is one phase, liquid is another phase in the first type, while in the second type solid is on one phase while gas is another phase. Okay. In the second variety, when liquid is used as a phase and the variety is liquid chromatography, another is liquid gas chromatography. Now the classification based on the shape of chromatography bed. When the planar chromatography technique is used, the beds are planar and the variety is plain paper, that is a paper chromatography, while on the glass plate the layer of the thin slurry material, and it is known as a thin layer chromatography, TLC. When the bed is a column and therefore it is called as a column chromatography. The first variety is a packed column chromatography and the second variety is open tabular column chromatography. In paper chromatography technique, the Whatman paper is cut to the required size, and from one edge of the paper the reference line is drawn with HB pencil. The reference line is also called as line of application, where The sample of the mixture is spotted using fine capillary. After spotting the sample, the paper is dried and kept into the solvent chamber, which is saturated with solvent vapors. The diagram showing the paper is kept with the help of thread or glass rod, which is hung into the solvent chamber. The solvent is rising through the paper, which is clear in the next diagram. Here, the direction of the solvent is in the upward direction due to the capillary action, and hence the type of paper chromatography is termed as ascending paper chromatography. The solvent is kept in the bottom, the paper is hung. The solvent passes through the spotting line through the paper and reaches to the required distance. The paper is hung using thread and clip. Now, after reaching the solvent to the required distance or required time, the paper is removed from the solvent frame and it is dried. If the separated components are colored, they are easily located by our eye, and if the separated compounds are colorless, then they are located by using detecting reagents like rubenic acid, ammonia solution. When the separated components are colored, then the distances are measured from the line of application, and these distances are the distance traveled by the solute from the line of application are measured for each sample, and finally the distance traveled by the solvent front is measured, and the ratio of distance traveled by the solute to the distance traveled by the solvent front is calculated, which is called as rate of flow value, that is a RF value. Another variety of same technique is thin layer chromatography. Here the thin layer of adsorbing material is made on the glass plate, and the glass plate is used for the separation of the mixture. The line of application is drawn from one edge of the plate and the sample is spotted on this line of application. The plate is kept for the development of the solvent in the solvent chamber. The plate is kept in the chamber for required distance or the required timing. When the solvent front reaches the required condition, the plate is removed from the chamber, it is dried. If the separated components are colored, then they are located easily on the plate, and if the separated components are colorless, then they are located by using detecting reagents. Finally, the distances traveled by the component from the line of application are measured. Also, the distance traveled by the solvent front is also measured, and the ratio of these distances is calculated as RF value. Now students, all these techniques you have learned in the lower classes. In this class, we are going to learn new techniques. These are the new techniques. The first one is column chromatography, and second one is ion exchange chromatography, and the last point we are going to see is the concepts in quality control. Column chromatography is a technique used to purify compounds depending on their polarity or hydrophobicity. In this method, a mixture of molecules is separated based on their differential partitioning between a mobile phase and stationary phase. Of course, column chromatography is a versatile purification method used to separate compounds in a solution. Here, the idea of stationary phase and mobile phase is cleared. Now there are 5 chromatography methods that use columns. Those are JC, that is a gas chromatography, LC, that is liquid chromatography, ion exchange chromatography, size exclusion chromatography, and the chiral chromatography. The basic principles of all these methods is the same. Now here the columns are shown. The main principle involved in this method is adsorption of the solutes of a solution through a stationary phase and separate the mixture into individual components. This is based on the affinity towards the mobile phase and stationary phase. That is, affinity of the component is important for the separation. Now we are going to see how the columns are prepared. Now these are the steps to prepare the column. First, place the column in the stand in the vertical position. Then, using the glass wool, use a plug of glass wool and it is pushed down to the bottom of the column. Then, the slurry solution of the silica gel is prepared with a suitable solvent, and this solution is gently poured into the column from the top. After pouring the slurry solution, the stopcock is opened and some solvent is allowed to drain out. Now these are the columns which are prepared. After introducing the sample into the column, they are developed by using elution technique. The individual components are separated out from the column by this elution technique. This technique involves the same solvent composition of solvent of same polarity used throughout the process of separation. For example, the solvent like petroleum ether and benzene in the proportion of 1:1 is used. Now after elution, the components are detected and finally the detected compounds are recovered from the column. The color components are detected by visual examination. They are seen to the eye. The colorless components can also be detected visually if they are giving fluorescence. Now after detecting the components, those are separated, must be recovered from the column. The recovery of the components on the column requires extraction of the column of adsorption and isolation of each zone for extraction with solvent. This is made successively, that is the bands which are present at the lower side are removed first and the band those are present in the upper side in the column are removed successively. While in the plastic tubing, the zones are isolated by cutting the tube. Now let us see the applications of column chromatography. Now it is used to isolate active ingredients, also used for the separation of mixtures, to determine drug estimation from drug formulation, to remove impurities, and to isolate metabolites from biological fluids. These are the applications of column chromatography. Students, with this I conclude my lecture. Thank you.